Okay, so we were trying to basically get the what we're trying to do is we're trying to get, so we got this derivative and stuff, and then we're trying to basically test if the expression equals what we got by applying the chain rule. So initializing the variables randomly, and then I was trying to just substitute this stuff. All right, and I believe it was just taking too long to run, right? Derivative, substitute this dictionary. This is, so in a way, this is what kind of helpful for the AI code assistants, right? Because this is like this just slows you down so much. You know what I mean? My point is, like, if you're not versed into technology, like if you're not versed, or you're not like, you know, great at using SymPy, or just like even just Python in general, right? The problem with this kind of stuff is that it just slows you down. Like you waste hours just trying to think about like how to, you know, is that mapping correct? Can I debug that quick? Whereas like if I would be confident enough that with the AI speed, that the AI, I wanna map that. That's what I want to do, right? I wanna map out using these initialization. I want to map out these symbols, substitute them, and then show these, right? What I'd like to know, what I like, you know, it's just that at least I know that it works well, right? So far, yeah, let's try to recap while this is running. Although it says 1 minute already. I don't know why it would take that long, but let's see. What we've done so far is basically define the metrics, define the forward pass, define the softmax. Then essentially, it's like we're essentially defining the layer, right? And all we're then doing is just saying do the derivative of loss with respect to W2, right? Why did it take so long for me to do that? I think it's just because I was getting a lot of errors here. Exactly. The same, right? This should have taken just a few minutes to do that. Like if I would know if the AI would be better at like kind of give me the code for these. And I wonder if I ask someone like Perplexity if they can, because this is pretty cool. Although Copilot, I've got like a restricted amount of usage for this because I'm not paying for it. The thing is, I'm tired. It's like it just sucks. You get so many different models out there. It's like I'm currently, you know, I don't want to end up like paying 20 bucks for like each model. Like there's the Replit one, okay. Then there is we've got ChatGPT obviously, but then Perplexity is using ChatGPT 4 in the background anyway. And then there's going to be Grok as well, hopefully available soon in Europe. Can you give me a code block that uses Python and SymPy to represent a neural network's forward pass, as well as the derivatives, some symbolic expressions. I don't know if it's something they can do nicely. I mean, while this is running. Oh, look at this. Okay. Actually, it took a while. It took 4 minutes, but it did something. And it did it. Oh, damn it! With respect to y true. Okay. Okay, let's do these. So I get a matrix. I get a matrix with respect to y true. Now, what we should do is, but it's good. It actually takes 4 minutes. Does it do this? Okay, interesting. We can look at these in a second. It just, for some reason, it took me so long. I don't know why. I think it was just because the debugging was a bit slow. Of especially these things, right? So how do you go about representing softmax functions? I remember, yeah, that's where I got stuck with the fact that when you sort of operate symbolically, you don't need to do some term correction that you need to do when you actually do the implementation. This is always that problem between like the theory on the papers and then the actual, how to implement the stuff then with code. Yeah, of course, why true. We need to do. Okay, so we need to do as well the thing with y true, right? The output size. We need to actually what is the actual variable called? Y true. Yeah. So can you see, like, can you generate also for y true? But then y true is just zeros and ones, right? But it doesn't matter, right? At the end of the day, I want to see whether I'm getting the same. Can you generate a random of y true as well, please? Are they kinder if you ask, please? Oh, that's well, actually. Okay, that's nice. Okay, that's actually very nice here, because it did not. Wow. Okay, that is nice. I'll post about these later. It did not only. Wow. Okay, so let me actually. Yeah, maybe that, I don't know. I have the feeling there definitely has been some sort of improvement, right? So let me just go to x.com and tweet about this. So I'll just kind of like screenshot that. So Raplitz, okay, so Raplitz AI. So Ghostwriter. It's not only. So did not only understand what I needed, but it also made suggestions. It sort of made suggestions that this change, like about places where this change would actually have an effect on, right? So I didn't only understand what I needed, but it also made suggestions that related to other parts in the code where the change might have had an influence. Pretty cool. So it did not only just initialize, like it did, like, yeah, crazy. Okay, that's pretty cool. So we'll get that there. So I'll get that here. We'll update the dictionary. We'll update the dictionary. and then the rest stays the same. Okay. Yeah. So I'll just stop it and then run it again. See what I get. So it should be like 4 minutes. And then let's see what I get. And then what we want to do is now, the next thing I want to do is I want to take that and essentially do the actual calculation, do the actual forward pass, and then do the actual backward thing. Okay. But let's see first if I get something out of that is just the actual like metrics, right? Because then I want to compare these two. What does these tell me? So can you give me a code block? Is Python and WinePy, SymPy. Sure. As an example for a password calculation for a single layer network. So what it does is it defines symbols, defines a sigmoid function, a forward pass, and then it does the derivatives with respect to the things, and then the chain rule to get derivatives with respect to W and wow. Okay, so now the question is like, okay, so can you, without using the chain rule, can you rewrite it using the chain rule? You know what I mean? I don't know if I'm gonna. What's going on here? Okay, let's just do it here. Let's just go here. Ask a follow up. Rewrite it, please, without using the chain rule. I want to avoid using the chain rule. That was kind of like my point at the beginning. I just wanna. What I want to see is this first principles thing, right? So one thing that I've noticed recently as well, as I kind of keep observing my kids learn stuff and just go through life, they're 2 and 4 year old, is how much important iteration is, and the fact that it almost feels like. Oh, I couldn't find an exact code example without using the chain rule. However, I can provide an alternative approach in a different method. Are you open? Are you open to using a different method? Yes, I'm open. Yes. Smiley face. See what happens. But note, what's interesting about this is like, note how it answered like I couldn't find any example instead of just I couldn't give you an example. Yeah, okay, just did a. Okay, so that's what I wanted. Because essentially what it does is DAZ, AZ, and then, yeah. So here it just does the step, right? But it's like here it just goes and says the derivative of A with respect to W, derivative with respect to A, of A with respect to B. Because your loss function A. I can generate images while search video, search image. Perplexity is pretty cool, to be honest. It's just maybe the interface is a little bit too much geared towards like search rather than kind of like conversation. But it's like it's interesting because it does. Okay, so let me see. Okay, it gave me something. That's cool. Now what I want to do is I want to compare these. So what I want to do is, so I want to take the NP generated variables. So now, okay, so now I want to take the NP generated, the NP variables. The NP generated variables, and in variables in main.python, and compute the forward and also the derivative. It's derivative with respect to W2, right? Derivative with respect to W2, so that I can compare if it matches with the symbolic substitution. See if it understands that. I mean, the thing is, it should, right? Why wouldn't it? I don't even like. Essentially, I don't know why I'm like. Why am I even doing that? So this is the forward pass. Then it's writing the thing. Then it's computing the loss and then derivative. Yeah, so this actually is using the chain rule because it's calculated that it's like A1 P transpose, like exactly. Okay, so that's fine, but then okay, so now that will be it. But then how do I compare the results? How do I compare that? I guess with the numerical derivative. It's pretty cool because it really gives the feeling that it's understanding what I'm trying to do, right? Because it's talking about the symbolic derivative, the numerical derivative. While I haven't really used those terms like directly and specifically there, if I just looking back at like my previous sessions around this topic, it seems it's improved a lot. Now let's see, right? If a visual inspection, okay, comparison. All right, let's just let it run. I'm not so sure if these will actually, so numerical calculations, if this will work right out of the box. It might not, so but let's see, because it will take a little bit. Okay, but I mean this kind of should work, right? This definitely should work. Once I'm done with these and I'm happy with these and see if I can then what is it that I'm aiming at doing, to be honest. Like because essentially sort of I need to kind of roll back my thinking. I was just going back to the example, right? Because I was trying to basically build that example from scratch, but I couldn't get the loss to go down. So I couldn't get the loss to go down. I remember that was the reason. And I think that led to that sort of like sidetrack. Yeah, but then I kind of can go back to the main thing and see whether I can get the loss to really go down, because essentially that's what I was trying to do, is just basically trying to build the whole thing from scratch, right? So the inputs, the forward pass, the backward pass, because I have my training here. Yeah, exactly. Yeah, then I need to kind of go back to this and see why this is not working, and then what I want to end up doing after these is just go and explore the actual frameworks out there that allow you to do some of these stuff without like the low level. it's impossible to know absolutely everything, right? But like you want to make sure that kind of work with the stuff so that you understand what's going on. 2 minutes. And so what I was saying before, what I was saying also is like the stuff with the iteration, right? It's funny in a way how it almost feels like the kind of kids just kind of go through something, right? And then there's some like in a way like this, it's like they won't probably understand or they just process what they're seeing, right? It's funny, it's just they kind of like process stuff, and sometimes they don't even give like necessarily interesting feedback out of these. But then the more they layer on top, the more they repeat something, the more they kind of like, and I'm just like looking at a specific example of like watching a movie, right? A more advanced movie, something like, let's say, Harry Potter, for like which is like, well, the first one is like 6+ recommended age, and like 4-year-old, you know, watching that, not really, you know, kind of grasping all the elements of it, right? But then as you rewatch it and rewatch it and rewatch it, I guess that kind of like what is it that it's doing, right? That's the interesting thing, because I almost feel like that practice is, and this is what happens with practice, right? So when they learn to copy stuff to sort of like improve the drawing skills, or like iteration seems to be the key. It's very funny. Iteration is the key, and it almost feels like with grown-ups we kind of neglect that in a way, right? It's like we just hope to see it, read through something and understand that, while, you know, it's like that iteration element is not that prominent there, right? And even like, yeah, you kind of do practice, even in the school system. If you think about like university school system, it's like you go through stuff, but you just go through stuff once, right? And then you're expected to do maybe exercises, recap stuff. Like that's maybe, I mean, that is maybe a name at, like, it's aiming at like trying to kind of recreate that like that repetition loop, but it's still not like yeah, I don't know. It's interesting, because I always wonder, is like whether even like with educational videos, right? So one would say, cool, so you've got you watch like an educational video, right? So you won't process what's going on there, right? And unless there's some sort of reward that allows you to then just say, I'm going to watch it again and again and again, until kind of like somehow you're paying attention to the points that you really have to, or like interiorizing the stuff that is being explained in there. I don't know. Just some random thought. Okay, so let's do this. There's a difference. Interesting. Okay. The symbolic derivative. First of all, it worked. I'm surprised it actually worked. Symbolic derivative and numerical derivative. And so there's an actual difference. Here's the difference matrix. Wait a second. Did actually like I didn't even take a look at like, oh, okay, it's cool. Like the actual code that it generated is interesting. It does actually then tell me that it is in a user-friendly way. Why do they differ? So let's ask, like, if the two differ, are there reasons why they would differ? So reasons: precision issues, implementation details, discretization error, numerical stability, gradient estimation. Yeah, well, that's definitely not the case, because we're using the same numbers. Or the tan function, then we're doing the, so this seems to be definitely the same. Softmax. Maybe these is what's not. There's the exponential though. well, here it's also, the thing is, I think it might be the softmax function. I think it might be the softmax function, because numerically speaking, there should be something. There's something that you do on the upper term, right? It was here. So softmax. What if we use the softmax that we had here? This one. Can I just replace it? Can I just replace these? Can I just comment these out? I'll try one more thing, and then I'll just. I don't think, you know, this might break actually. So this might break actually. So I don't know. But this might be one of the things where the, you know, where there's a difference, right? Because there's this max correcting term in here, which symbolically speaking, when you use the symbolic stuff, it's not needed. Maybe, well, maybe no, it's definitely not needed. Also, then when you're doing the substitution, I don't know, then in a way it should be, right? So that is definitely like a problem, or would be a reason, right? So I can also try to then remove softmax altogether from both calculations. Maybe that's even better. Let's just stop these. Let's just say y pred is z2. Let's just ignore softmax. And here, also just say these. Let's see if that's, because I know that in a way that, you know, that's maybe the wrong thing to do, but at least I want to see if that's what introduces the difference. You know what I mean? And that's it. And we'll leave it here. So let's see. That took like 7 minutes. So let's so we'll yeah, we'll look into the, oh, whoa, invalid. What happened now? Invalid value encounter in lock loss NP. I mean, 93 Y invalid value encountered in lock loss NB. Okay, I need to figure this out. I'll figure this out next session, but it seems like this could definitely be lock loss. So what is lock loss then used for? Is it used at all afterwards? Why are we calculating the, well, actually it does seem like that's the reason, because now the numerical derivatives are, look, they're kind of this almost the same, at least. Yeah. There's some signs that are changed, but essentially the values are almost the same. Interesting. So yeah, there's kind of a nuance there, I guess. They're almost the same, but I'm not so sure. I'm not so sure if what I'm doing is almost the same. Something's wrong here, but it doesn't matter because that's not used anywhere. The derivative is based on derivative substitute. Oh, what? Wait. Okay, what is wrong here? So, I know. So what is that calculated? Oh, it's all good. It's all good. Derivative NP. Yeah. Symbolic. That's a funny way to name the variables. Anyway, W2NP. that is the numerical one. That is this one here. So it's using that. It's using that. A1P TZ. This DZ is basically this minus this gradient loss function. Okay. So essentially loss NP is not needed at all, is it? We don't need to calculate that loss. Now for this comparison, right? That's what I mean. It's like it seems like that's guys, I have no idea why it even like continued. You know what I mean? Oh, there you go. Numerical derivative, symbolic derivative. Oh, no. Oh my god. Oh, I'm so stupid. Symbolic derivative. It does actually. Oh, why is that so different than before? Yeah, something's odd. Symbolic derivative? Why is it all zeros? I was comparing the wrong thing. I was comparing the difference with the numerical derivative. That's stupid. Yeah, they're definitely different. Okay, that's not good. It's definitely not good, even without the softmax function, right? Even without the softmax function in there. So we'll keep investigating. I mean, at some point, it's like the return on investment on this investigation will need to be challenged, but we'll keep in. Oh, what am I doing? We'll keep. That's fine. We'll just go back to the latest point anyway. See you next time.